Okay guys, so today we're going to look at inequalities with polynomial functions. And so what I'm going to try to do with you guys is just walk through a couple steps with you, just to kind of how we solve inequalities with polynomials. This first one's just going to deal with quadratics, and then the next video is just going to deal with polynomials that are not quadratic, so like cubics or quartic equations, okay? So if you guys look on the first page, you guys do have some like open spots here, and this is the process that we're going to go through. There's like 5 steps to kind of help go through this. The first thing that we're going to do is just make sure that we express the inequality in f of x is less than 0 or f of x is greater than 0. It means that we want one side to be 0. Then we're going to solve for that function. So that means we'll have to factor it and then set each of the binomials equal to 0. We're going to make a number line that kind of identifies what those zeros are. And then what we're going to do is we're going to try to use those zeros and help identify what values make this inequality true. And those values that we're going to use are going to be considered to be test values. And then we're going to try to write down what the values are in interval notation. So let's just kind of walk through one example. This one's already factored out, and so like in this case, this first step is already identified. All right, so we already have one side being 0. So we have x minus 4 times x plus 2 is greater than 0. So the next thing that we got to do is solve the inequality. It's already factored out, so all we really have to do is set x minus 4 equal to 0 and x plus 2 equal to 0. And so what we see is that our zeros are 4, and they are also negative 2. So what I'm going to do with those two values is I'm going to put negative 2 as one of the zeros and 4 as one of the zeros. And what I'm going to do next is I'm going to make a number line. And what I want to do is I want to find the values that make this inequality true. So the two zeros I have are negative 2 and 4. And so what I'm going to do is I'm going to identify some test values. A value that's less than negative 2, so like if I choose like negative 3, that value works. I'm going to choose 0 because 0 is between negative 2 and 4. And then I'm going to also choose a value that's greater than 4, so I'll choose like 5. And what I'm going to do is I'm going to plug each of these values. I don't have to plug negative 2 in because I know it's 0. And I know 4, if I plug that in, it's going to be 0. But I'm going to plug negative 3, 0, and 5 into this inequality. I plug this into my calculator, kind of like what I have here. I'm going to press enter to see what I get. I know it's 7, so I'm comparing 7, and is that greater than 0? Yes. So that means anything to the left of negative 2 will work. I can plug another value in if I'm not sure that's less than negative 2, but I do know that it's going to be true. I'm going to put an open circle here at negative 2, and I'm going to move my arrow this way because I know anything to the left of negative 2 works. Now I'm going to plug 0 in. So I'm going to do 0 minus 4 and then 0 plus 2. And when I do that, I got negative 8. So when I look at negative 8, is negative 8 greater than 0? I know that's not a solution. I do know that this is a solution. Okay, and then the last one I'm going to choose is 5. So I'm going to do 5 minus 4 and then 5 plus 2. And I'll press enter. And I got 7. So 7 is greater than 0. So that is a solution. So that means that I'm going to go from 4 to infinity. Now, the reason why these circles are open is because it's not equal to, it's less than, or it's greater than. So, in this case, I know my solution is going from negative infinity to negative 2 and 4 to infinity. So my interval notation would be from negative infinity to negative 2, union 4 to infinity. Okay, that would be the solution to that set, or to this inequality. Okay, so I'm going to ask you guys just to pause the video. I'm going to ask you guys to try this one, and then when you guys are done, I'm going to ask you guys just to check what the solution is. Okay, so just same process that I did before. I'm going to set the inequality well, so that one side's 0, and that's still the case. Now I'm going to set each of the binomials equal to 0. So I got x to be negative 1. I got x to be 7. After that, I made my line, number line, and I put negative 1 and 7 on the number line. Then I chose some values that are less than negative 3, and then I chose a value that's between negative 1 and 7, and then I chose a value that was greater than 7. Plug those values in. I saw that negative 3 is not a solution to that inequality, so that's not included in the solution set. And then I plug 0 into this inequality. And when I plug 0 into that inequality, I got negative 7, which is less than 0, which is a solution set. And then I plug 10 into the inequality. And when I did that, I got 33, which is not greater than, or is not less than or equal to 0, which is not a solution. So all my values, or all my solutions, are between negative 1 and 7. And it's solid because it was less than or equal to. So my values are between negative 1 and 7. Okay? So now let's look at another type of question, just kind of adding to this. So we're looking at 6x squared plus x is greater than 1. Well, my first step is I got to get one side to be 0. So I got x squared plus 1x minus 1 is greater than 0. So it's not factored out, so I'm going to have to factor it out. I'm going to take 6 times negative 1, which is negative 6, and I'm looking for a sum of 1. So that means I'm looking at 3 and negative 2. So I'm going to use that to help factor this out. So I got 6x squared plus 3x minus 2x minus 1. Greatest common factor between these two terms is 3x, which I get 2x plus 1. And then minus 1 is the greatest common factor, so I got 2x plus 1. So my factored form is 3x minus 1 and 2x plus 1. Okay, so in that case, I know that x equals 1/5 or 1/3, and then I know that x equals negative 1/2. So on my number line, I am going to choose negative 1/2. That's one of the zeros, and then I'm going to choose 1/3. I'm going to choose a value that's in between negative 1/2 and 1/3, which is 0. And then I'm going to choose values. I'm going to choose like negative 1, or I'm going to choose, we'll choose like 1, and plug those into this inequality to see what's true or what's not true, or what makes them true. Okay. So like if I plug 0 into this, I would end up with 0 is greater than 1, which is not true. So in between is not a solution. Now I'm going to plug negative 1 and 1 into this. Plug negative 1 into this, I got 5, which is greater than 1. So that is a solution. And then I plugged 1 into this. So I got 6 times 1 squared plus 1 is 7, which is greater than 1, too. So that is a solution. So that means that anything that's a open circle to the left is true, and anything to the right is true. So my solutions would be from negative infinity to negative 1/2, union from 1/3 to infinity. Those would be the solutions to this inequality. So I'm going to ask you guys to pause the video, try this one out, and see what you guys get. So when I did this, I got my factored form to be 3x plus 1, x plus 5. So that means I got x to be negative 1/3 and negative 5. So I chose negative 10, negative 2, and 0 in this inequality just to see what works. And I found out that negative 2, when I plugged negative 2 into the original inequality, I got negative 20, which is less than negative 5, which is a solution. So my solution became negative 5 to negative 1/3. Hopefully this helps you guys out. The next video is going to help you guys look at some other types of inequalities. Cubic